Okay, so this is the review for the Unit 9, the probability. Definitely make sure you've got your calculator out because I'm not going to be putting the calculator up. I'll tell you what you should be putting in on the calculator, how it should go in. This first particular one talks about the gumball machine contains 12 red, 15 white, 6 blue, and 9 purple. The machine dispenser randomly selects one gumball. We're looking at one gumball being selected. That's it. It's a one-shot deal. So what are the following probabilities? Well, the first thing you need to realize is that there are 42 total gumballs. So 42 in total. How many of those 42 total are white? And the probability then would be 15 out of 42. I would prefer that you do not simplify these. Well, if 15 out of 42 are white, then how many are not white? And 42 minus 15 gets you 27 out of the 42 that are not white. Red or blue, this is not doing two separate draws, this is one draw. So if there's red that are 12 and there's 6 that are blue, this is just a total of 18 out of the 42 are either red or they're blue. What's the probability there's an orange gumball? Well, that's kind of a silly question. There are no orange gumballs at 0 out of 42. Find the number of permutations from the letters in the name Connecticut. Well, here's the idea where we need to find out, are there any repetition in the letters and how many letters exist? As you count up the letters of Connecticut, it turns out that there are 11 letters, of which there are 3 C's, there are 2 N's, and there are 2 T's. So the idea is it's a factorial. It's an 11 factorial, but it's divided by the repetition, and the repetition must be in parentheses, because if you don't type it in on your calculator with parentheses, you're going to get the wrong answer. And in the parentheses, it's a 3 factorial followed by a 2 factorial followed by 2 factorial again. This goes all into your calculator. 11, math, probability. I believe the factorial is choice 4. Divided by parenthesis, 3, math, probability, factorial, etc., etc. So hopefully you've got the calculator part down. If not, you're going to ask tomorrow. It's 1,663,200 combinations. Next one. How many 5-digit numbers can be formed from the digits 5, 6, 7, 8, and 9 if no digit may be repeated and there are no restrictions? Well, if there are no restrictions, that's a straight 5 factorial. It's a straight 5 factorial, which is the same thing as a 5p5, which is the same thing as the box method, 5 times 4 times 3 times 2 times 1. This comes out to be a total of 120. Well, what about if the number is going to be even? Well, the only way a number can be even is if it ends in an even number. So again, I've got to have 5 numbers in my digit, and I could end in either the 6 or I could end in the 8. Well, if I look at my digits, there's only one 6. Once I've used my 6 and that comes out of the mix, there are 4 other digits left to choose. Pick another digit. 3 digits left to choose, pick another digit, and so on and so on. Well, here's the other case. We know that if we want the number to be even and it ends in an 8, there's only one 8 to choose from. 8 gets chosen. It's already now used. How many numbers are left to choose? 4, pick one, 3, 2, 1. So this becomes 4 times 3 times 2, which is 24, or addition 24. This final answer right here is 48 ways. What if you want your number to be greater than 70,000? Well, if I put a 5 in the 10,000th position, that's a 50,000 number. If a 6 goes in for my first digit, that's a 60,000 number. If a 7 goes in, that's a 70,000 number. And the smallest it could be would be 75689, 75,000 and change. 7 would work. Obviously, 8 would work and 9 would work. So I could have 7 first in my 5 digits, or I could have 8 first in my 5 digits, or I could have 9 first in my 5 digits. When I do my restrictions, there's 1 7. Once I use the 7, there are now 4 numbers left, followed by 3 choices, followed by 2, followed by 1. Start all over. There's 1 8. use the 8. There are 4 numbers left to choose from, then 3, then 2, then 1. I think you've got that picture here. If I start up with my 1, 9 that I have to choose from, and I use my 9, there are 4 numbers left, then 3, then 2, and then 1. So when I look at all of this, I've got 4 times 3 times 2, which is 24, but it's 24 here, or 24 choices here, or 24 choices here. So for a number to be greater than 70,000, it would be 72 choices. Okay, so this one, a store shelf has 7 rock CDs. It's got and 4 rap CDs. 2 CDs are chosen. This is now where 2 things are happening. This is the and or the or with the multiplying. A CD is chosen, or 2 CDs are chosen, but there's no replacement. So what's the probability that you're going to get both rap? So essentially you're saying, what's the probability that I'm going to get rap and then rap again? Well, I've got 11 total CDs. I've got 4 out of 11 chances to get rap the first time, and then I've got 10 CDs left, of which 3 of them are rap. So I've got 4 11ths times 3 tenths, which equals 12 out of 110. Don't simplify it. When we go for the next one, what's the probability that they are both rock or both rap? Well, that means the probability of getting rap and then rap again, or the probability of getting rock and then rock again. I am just going to take what we did from the 12, 1, 10. This is just going to go right here. Okay, we just did that in A. This is a plus sign. So rock and then rock. Well, out of all of my, excuse me, out of all of my CDs, I've got 7 out of 11 that are rock. If a rock comes out, doesn't go back in, 6 rock left out of 10 total. This becomes 42 out of 110. I have to add it to my raps, and now if I add 12 out of 110 and 42 out of 110, I get 54 out of 110. Next one. Okay, so I don't believe I have a dice chart up here. So tomorrow for sure we're going to have to talk about this. But an experiment consists of rolling 2 die at the same time. What you need to understand for the die, and I don't have it to show you right now, so you'll have to take my word for it, and we'll talk more about it tomorrow. But there are 6 sides to one die, and there are 6 sides to the other die, so there are 36 total outcomes. Well, if I roll the die, right, I can get a 1 with a 1, I could get a 1 with a 2, I could get a 1 with a 3, a 1 with a 4, a 1 with a 5, and then a 1 with a 6. But just understand, and again, I'll show you more tomorrow, that getting a 1 and a 1 is very different, or getting a 1 and a 2 is very different from getting a 2 and a 1, or like a 3 and a 1. Okay, so we're going to have to show this to you tomorrow, but let's just at least give you the basis of this since I don't have the die chart up here on this particular smartboard. So what's the probability that the sum of the 2 dice that you roll becomes odd? Well, if you start taking all the choices, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, 3, 2, I think you're kind of getting the picture, and you add up those 2 numbers that show up on each die, well, half the time the sum is going to be even, half the time the sum is going to be odd. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. It's going to be even, odd, even, odd. So there's 18 times out of the 36 outcomes where my sum is odd. Well, if I do a dice chart and I look for the sum being less than 6, and I'm going to write this one out for you, I could have a 1 with a 1, I could have a 1 with a 2, a 1 with a 3, a 1 with a 4. I could also have a 2 with a 1, a 2 with a 2, a 2 with a 3. I can't have the 2 and the 4 because that is 6. I could have a 3 with a 1, a 3 with a 2. I could have a 4 with a 1, and then you're done. There's no other ways to roll the die and get sums less than 6. So there happen to be 10 ways out of the 36 where the sums are less than 6. So out of those 10 ways, look at C, we want the sum to be odd and less than 6. Well, the ones that are odd and less than 6 is the 1 and the 2. That's odd and less than 6. The 1 with the 4 is odd and less than 6. The 2 with the 1 is odd and less than 6. The 2 and the 3, as well as the 3 and the 2, remember those are two different rows, as well as the 4 and the 1. So there are 1, 2, 3, 4, 5. There are 6 ways out of these 36 where my sums are odd as well as less than 6. And again, you need to understand that rolling a 1 and then a 4 is very different from rolling a 4 and then a 1, especially if your die were colored. So if we want the sum to be odd or less than 6, we have to understand that there's an overlap. So we know from A, 18 out of the 36 die are going to be odd sums. 10 out of those 36 die are going to be less than 6, right? 18 are odd, 10 are less than 6. But wait a second, 6 of them are both. I can't count the same throw twice. I have to subtract the overlap, the intersection. So what happens is I get 28 minus 6, which becomes 22 out of 36. Definitely we'll be talking more about that tomorrow, don't worry. All right, let's keep going. Tasha, 6 dresses and 3 pairs of shoes. How many dress shoe outfits are possible? Basic counting principle, 6 times 3, 18 outfits are possible. Printer, 3 colors of paper, 5 types of print. How many color print combinations? Well, 3 of that, 5 of the other, 15 total. A restaurant offers 3 meats, 6 veggies, and 4 desserts. How many meals, consisting of 1 of each, are there? Counting principle. Once again, I've got 3 choices of one thing, 6 of another, 4 of the last, and then when I multiply this out, I'm going to get 72 meals. Okay? Counting principle, just multiply the different possible outcomes. Write the set of all numbers greater than -3, but at the same time less than or equal to 5. So I'm dealing with my smallest number and my largest number. The fact that I'm greater than 3 will be an open circle, which means I've got a parenthesis. The fact that I'm less than or equal to means I'd have a closed circle or I'd have a bracket. There's your interval notation. Parens, -3, comma, 5, bracket. On Peter's birthday, his dad puts a $1 bill, a $5 bill, and a $20 bill into a container, a covered container, and tells Peter you can reach in and get out 2 bills. You're reaching in once, and then you're reaching in again. You're not putting the 1 bill back. That'd be silly. So it's out without replacement. Draw a tree diagram or list the sample space. I'm going to go for the tree diagram. On my first pick, he could pick a 1, or he could pick a 5, or he could pick a 20. Well, if Peter picks a 1 the first time, then what's left in the jar is either the 5 or the 20. If Peter picks a 5 the first time, then what's left in the jar is either a 1 or a 20. If Peter picks a 20 the first time, then what's left in the jar is either a 1 or a 5. So if you look at all the different possible combinations in the sample space, I'm not going to do all of it, but the sample space would be something like this. He could pick a 1. I guess I would do 1-5. I don't know. It'd be a 1-5 or a 1-20 or a 5-1 and a 5-20 or a 20-1. I guess I am doing all of it, or a 20-5. So those are 6 possible outcomes. If his dad promises to give him the total value of the two bills he pulls, what's the probability that he'll end up with more than $20? Well, that should be pretty easy. Let's see. If I want more than 20 bucks, I've got more than $20 here, that's $21. I've got more than $20 here, that's $25. I've got more than $20 here and more than $20 here. So if I do what his dad says, we could have 4 ways out of the 6 that he's going to end up with more than $20. Set A, those are your numbers. Set B, those are your numbers. If you want to have the AUB, it's the union. It's the marriage of the two. It's everything that exists. I'm going to start from the one on the left, and I'm going to say -2, 1, 3, 5, 10, 12. I'm going to look at set B. -3 I have not used yet. 0 I have not used yet. 1 I have. 4 I have not used yet. 6 I have not used yet. 10 I have. 11 I haven't. So all the numbers that are included in both do not repeat any numbers. That's what your union is. The other one is the intersection. It's what's common to both. In set A, that's also in set B, it looks like I've got the 1 in both numbers or both sets, and I've got 10 in both sets. There you go. That's your intersection. Take a look at the Venn diagram. Find everything that's not in the circle of A. Well, what's not in the circle of A? No particular order. 56 is not in, 48 is not in, 40 is not in, 16 is not in, and neither is 24. What's not in set B? 56 is not in, 48 is not in, 40 is not in, but then neither is 8, 32, or 64. Next. Construct a Venn diagram, show all your work. Where is that one? There are 122 people in the freshman class, 56 are in Spanish, 31 are in French, and 3 take both languages. How many don't take either? So I've got a circle that's going to represent Spanish. I've got a circle that's going to represent French. You could put a rectangle around everything if you want. I might as well do that. The rectangle I'm not as concerned about, but there are 120 kids total. That's like your universal set. We'll work from the inside out. 3 kids take both languages. Well, they want 56 in Spanish. I already have 3 in Spanish, so that means 53 are only Spanish, while 3 are in both. So I've got 53 on that side. My French is 31 kids. Well, I already have put 3 in French, so 31 minus 3 is 28. Here's 28. If I add up all those numbers right now, 53 plus 3 plus 28, that's going to come out to be, I believe, a total of 84. And then if I take the 120 students, subtract it by the 84, I get 36. So 36 don't take either language. There's your answer. Okay, the next one. Which of the following numbers cannot represent the probability of an event occurring? So the choice is -1/2, 0, +1/2, or 1. This would be the one. There's not a negative chance something happens. Your probability is on the spectrum or the continuum of 0, it never is going to happen, 1, it's always certain to happen, or 50%, 1/2, maybe yes, maybe no, and anything in between. You can never have a negative value. Which of the graphs below shows a solution set? Parenthesis means open circle, 0 means closed circle. Definitely can't be these because it wouldn't be what we haven't done any of that. So open then closed. Only going to be that one. 16, if cards are numbered 22 and one card is chosen at random or drawn at random, which of the following has the greatest probability of being drawn? So out of 22 numbers, 11 of them would definitely be even. 11 of them, whoopsie, would definitely be odd. A card with a single number digit, well, the single number digit would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 9 choices. And a card with a 2-number digit, well, that's going to be everything else. So that's going to be 13 choices. So which one has the greatest probability? Well, of course, it's going to be the 13 out of the 22. Oh, I guess that's it. Okay. For some reason, I've got other stuff on my paper, so I'm wondering if maybe you have some other questions that I did not give you. And if that's the case, you'll let me know tomorrow. But that's it. So good luck. See you tomorrow.